Hello everyone, welcome to our channel Learn Day by Day. Please subscribe and support Learn Day by Day. Today we are going to see about the seminar topic about Maglev train. Maglev train is amazing and fastest train. Let's go and see the Maglev. We all are have a doubt what is mean by maglev. I will tell that maglev equal to magnetic plus levitation. Anything may levitate, raise or flow by means of magnetic power is simply called as magnetic levitation. Maglev is a system of train transportation that uses two set of magnets, one set to repel and push the train up of the track and another set to move the elevated train ahead, taking the advantage of lack of friction. Maglev is the system of transportation that suspends, guides and propels vehicles, predominantly trains using magnetic levitation from a very large number of magnets for lift and propulsion. This method has the potential to be faster, quieter and smoother than wheel mass transit systems. Next we are going to see the principle of maglev train. The basis of maglev train mechanism or magnetic levitation. This is achieved with principle of repulsion and attraction between two magnetic poles. When two magnets have the same pole, it will repel each other, and when it has different poles, the result would be otherwise. Maglev trains have to perform the following function to operate in high speeds. Here there is a diagram about the three functions. One is the levitation, propulsion and the lateral guidance. We can see this one by one. First we can see the levitation. The levitation meaning in Latin word meaning lightness, process by which an object is suspended by the physical force against gravity in the stable position without any solid physical contact. Principle is first a force is required vertically upward and equal to the gravitational force. Second, for any small displacement of the levitating object, a returning force should appear to stabilize it. Here the diagram of the levitation, the passing of the superconducting magnets through levitation coils on the side of the track induce a current in the coil and create the magnetic field. This pushes the train upward so that it can levitate 10 cm above the track. Next we are going to see the propulsion. An alternating current is run through electromagnetic coil on the guide walls of the guideway. This creates the magnetic field that attract and repel the superconducting magnet on the train and propels the train towards. Braking is accomplished by sending an alternating current in the reverse direction so that it is slowed by attractive and repulsive force. Last, we can see the lateral guidance. When one side of the train near the side of guideway, the superconducting magnet on the train induces a repulsive force from the levitating coils on the side closer to the train and an attractive force from coils on the farther side. This keeps the train in the center. Next, the levitation system power supply. Batteries on the train power the system and therefore it still functions without propulsion. The batteries can levitate the train for 30 minutes without any additional energy. Linear generator in the magnet on the board. The train uses the motion of the train to recharge the batteries. Levitation system use less power than the train's air conditioning. There are the two types of maglev system. One is the electromagnetic suspension and another one is the electrodynamic suspension. First we are going to the electromagnetic suspension. It is an attractive type of system. Magnet guideway geometry is used to attract a direct current electromagnet towards the track. EMS levitates the train about 1/3 of an inch above the guideway. The maglev train in German works on the electromagnetic suspension system. Next is the electrodynamic system. First we saw electromagnetic suspension is the attractive type. This one is the repulsive type of the system. Electrodynamic suspension used by the Japanese is in the idea that same two electromagnetic force are positioned at the undercarriage of the maglev train, and on the track this creates a repulsive force because two like force repel, thus resulting in the levitation of the maglev train. In addition, electromagnetic force are positioned on the side of the guideway. This creates a propulsion, the force in which the maglev train moves forward. The propulsion is created when magnetic fields are created from electricity flowing through the superconductor on the guideway tracks. How does the magnetic levitation train work? The magnetic levitation train operates based on one out of the four fundamental forces of nature, the electromagnetic force. The maglev train basically function by using the attraction and repulsion of electromagnetic force to move the train forward while levitating. Next, we are going to see the advantage and disadvantages. First, advantages. These trains are weatherproof, which means rain, snow or severe cold do not really hamper their performance. Maglev system are energy efficient. More importantly, there is no physical contact between the train and the track. So there is no resistance. Disadvantage. The maglev track is much more expensive than railroad track. Use of very powerful electromagnet make it costly. The application of the maglev train. While the maglev technology has been developed and as the future of train transportation for decades, there are only a handful of countries operating maglev train around the world. There are China, South Korea and Japan. We are at the end of the video. Last is the conclusion. Temperature affect a magnetic levitation train because when it is cold it runs a lot faster, the magnets ride closer together and with less effort to move ahead. The result in the end is temperature does affect how the train runs. Thank you.